For part 2 of this week, in which we talk about numerical data, we are going to talk about describing variation of a numerical variable. This is also known as spread or dispersion. So far we've talked about a measure of central tendency and measures of position or location. But sometimes you want to know how spread out a set of observations or data points are. And for that, we want to talk about measures of variation. So just to be clear, these measures of variation or spread include the range, the interquartile range, the variance, and the standard deviation. So we've talked about personal income, and we have this data set of personal income. We have two columns. These two variables are income and age, and then we have about 1,000 rows, 1,000 observations. And we've talked about what the measure of central tendency is for the income distribution, and we have an idea about position or location of the data. So we know what incomes are for the bottom and top 1% and other percentiles. But we also want to know just some kind of measure about the overall spread or dispersion or variation. To put it another way, we might want to ask how much variation is there in the income of people in this data set. Well, there are several different ways of really talking about measures of variation. As I mentioned earlier, these measures of variation are known as spread, dispersion, variability. That all means the same thing. When we talk about the mean, the median, and the mode, those measures of central tendency, they give us information about the middle part of a set of observations. It gives us an idea of what sort of the typical observation is in a set of observations. But these measures really don't tell us much about the spread, the dispersion, the variability of the data. And for that, we talk about measures of variation. There's several different kinds of measures of variation, but let's go through sort of an example of one. So suppose you have these two sets of observations. You have a set of observations that are simply 5, 5, 5, 5, 5. So you have 5 data points, all exactly the same. Then you also have a different set of observations of 1, 3, 5, 8, and 8. Now just looking at those two sets of observations, I think most people would say that the second set, it has more variability. You just see that the data points differ more for the second data set than for the first, because the first data set consists of the same value repeated 5 times. You simply have 5, 5, 5, 5, 5. The one point, though, is that if you just look at a measure of central tendency, for both of these data sets, the mean and the median is the same. For both, the mean is 5, and for both, the median, or the 50th percentile, is 5. So measures of central tendency don't always get at the sort of idea behind the variability, the range, the variation of the data set. And so for that, we need different measures. So the other point I would say is that the mode differs slightly, but it still doesn't tell us much about the variability. For the second data set, the mode is 8, and for the first data set, the mode is 5. So we really want to think about measures of variation as separate from measures of central tendency. The most commonly used basic measure of variation is the range, which is really simply the difference between the maximum and the minimum value of a set of observations. It's as I mentioned, it's the most commonly used measure of variation, and it's also just the simplest. You often see people just talk about, when you have a set of observations, the sort of first step is just say, well, what's the maximum value and what's the minimum value? Just as sort of a first grasp of how varied a set of observations are. So let's look through an example. In this first, suppose you have a small set of observations of 1, 2, 3, 4, and 5. So you have 5 observations with these sets of values. The range is simply the max value minus the minimum value. So the maximum is 5, the minimum value is 1 for that first set of observations, and so the range is 5 minus 1, or 4. Suppose you have a different set of observations of 1, 2, 3, 4, and 10. So in that last observation, instead of 5, is now 10. So we've included an outlier here, an extreme value. And the range is, again, the difference between the maximum value and the minimum value of this set of observations. The maximum value is 10, the minimum value is 1, so the range is 10 minus 1, which is 9. So you can see that in these two basic examples, the inclusion of that outlier, that extreme value, it is reflected in the range. The range differs, and the range is reflecting the greater variability when we change that last value from 5 to 10. So you can see that the range does function as a way of capturing some degree of variability in a set of observations. There are, however, a few problems with the range as a measure of variability or dispersion or spread. First of all, the range, what it does is it neglects the information within the range. So range is simply the maximum value minus the minimum value. But all those observations in between those two endpoints are effectively ignored with the range. And so the range is not going to capture the variability within those two endpoints. So for example, suppose we have a set of observations, a small data set that consists of 1, 2, 2, 2, and 5. So that's sort of a basic small data set. The range in that small data set is simply going to be 5 minus 1, which is 4, okay, as we've talked about before. But suppose, for example, that those three middle numbers, instead of being 2s, are in fact 5s. Well, in that case, the range is still 4. But the second version of the data set actually has less variation because you have 4 5s instead of 1 5. So the problem is that effectively the range ignores the three middle numbers of this small data set. And so it's not capturing all of the variability in the set of observations. And that's one limitation. Another problem with the range is that it is in fact sensitive to outliers. Because the range is really just the two, based on the information from the two endpoints, just altering one of those two endpoints can really change the measure of variability in a way that might be misleading if it's based on only a few outlying points. So for example, in the first case, when you have a set of observations of 1, 2, and lots of 3s, the range is going to be, is simply going to be 3, all right? But what happens if you change that last data point from a 3, okay, or 4 into 95? Well, the range is going to be 95 minus 1, which is 94. So you can see that the range is quite sensitive to how these extreme endpoints are changed, because it's based on the endpoints. If you change one of the values of the endpoints, the range will change. So another way to put it is that the range is sensitive to extreme values, otherwise known as outliers, right? The range changes based on just the alteration of one data point. So let's look at our data set of personal income and calculate the range as a measure of variability. So already, when we do a basic tabulation, we can see that the maximum value is a little bit over $1 million. And then the minimum value is $0. So in our data set, we have these two values of the maximum and minimum values. The range is simply the difference between those two. And so the range is 1,203,000 minus 0, which gives us $1,203,000. So that's the range of the set of observations in personal income. That's a lot of variation, but as I mentioned earlier, one problem with the range is that it is sensitive to extreme values or outliers, meaning that range might be based on just one person making a lot of money, one person making $1,203,000. And so we want to think about other measures of variability or dispersion that are robust, that is insensitive to extreme values. Different measure that is more robust to extreme values is something known as the interquartile range. So the range is simply the maximum and minimum values, the difference between those two. The interquartile range is the difference between two locations within the data set that are based on the third quartile and the first quartile. So the interquartile range is the difference between the third quartile and the first quartile. To put it another way, the interquartile range is based on the difference between the 75th percentile and the 25th percentile. It's really this range reflecting the middle 50% of the set of observations. What's useful about the interquartile range, since you're looking at the sort of middle part of the data, it can eliminate some outlier problems, especially in the tails of the distribution. When you have extreme values, either in the high end or the low end, the interquartile range is considered more robust to the problems of extreme values affecting a measure of variability or spread. So let's look at our data set and calculate the interquartile range and compare it with the range. The interquartile range is simply the difference between the 75th percentile and the 25th percentile. So to put it another way, we're trying to find the difference between the third quartile and the first quartile. Remember, the third quartile is the 75th percentile and the first quartile is the 25th percentile. So when we look at that difference, we have $48,000 is the 75th percentile. So 75% of people on our data set make less than $48,000. And then the first quartile, the 25th percentile, is $8,600. So 25% of people in our data set make less than $8,600. When you look at that difference, we have the interquartile range. The interquartile range is $39,400. So to put it another way, this measure of variation based on these quartiles, it gives us an idea of the range of the middle 50% of the data. 50% of the observations are in that middle part between the third quartile and the first quartile, and that range gives us an idea of how varied that middle part is of our set of observations. Now, if you compare the interquartile range with the range, notice that it's much, much smaller, and that reflects the fact that the interquartile range is more robust. It's less sensitive to outlying or extreme values. And with that, we will talk in a little bit about other measures of spread and variation that you might encounter.